What's happening, dogs? Mr. Allen here, about to solve some exponential equations here. And these ones are rather tough, okay? Oftentimes you look at them, you're like, I have no clue. I'm skipping it. Maybe I'll come back to it later on in the test, but I got you, okay? So, first one here. We got 4 to the 2x minus 6 times 4 to the x plus 5 equals 0. I see this 4 to the x and kind of a 4 to the x right here, but not really. Okay, so maybe there's something with that. Could I rewrite this 4 to the 2x? And would this be mathematically legal? You tell me, okay? 4 to the x squared. I didn't hear anybody say no. So I'm going to say that this is okay, all right? So this is cool. Remember, power to a power means that I multiply the exponents. So I can go the other way with that, right? So here I have my exponents multiplied. I'll just undo the power to a power, put it back like that. Cool? And now I have minus 6 times 4 to the x plus 5 equals 0. Okay. Now this 4 to the x, here's what we're going to say. We're going to let u equal 4 to the x. Okay? We often use U-Substitution in math. You'll start seeing that more and more. Okay, especially when you get into calculus, you'll see that. But u is just a common variable for that because it's not one that's used for a whole lot of things, so we just use u. Okay, there we go. That's the whole reason. So I'm going to have u squared minus, we got 6. That could become u, right? Plus 5 equals 0. Ooh, I have myself a quadratic equation, which I can hopefully factor and solve. Let's see here. Does anything multiply to 5 and add to negative 6? Why, yes, it does. Negative 5 and negative 1. Nice. Be careful when the numbers are that close together. A lot of people are like, oh, it's, 6 and negative 1. And it's like, no, it's not, because that, you don't want to mix up what you multiply and add to, especially when you're in these complex, math situations. You start forgetting your basic math or your older math. Be careful. Okay. So now what I'm going to have is this one's going to give me u equals 5, and this one's going to give me u equals 1. That's not my answer, though. U equals 4 to the x. So we got to go back to 4 to the x being u. That equals 5. And here 4 to the x equals 1. Well, I can solve this one here. It's got to be 0. Right? Anything to the 0 power is going to be 1. So that one's good. But this one here, I got to do a little finesse work, okay? I can't write 5 as a 4 to a power or 2 to a power or anything like that. So I'm going to loop and swoop this thing. Okay, I'll do that in a different color. Loop and swoop. Whoop. Put it in the log form. So I'll have log base 4 of 5 equals x. Okay? They often say like logs are exponents. You may have heard that before. My exponent is equal to this log. Okay? So I can't evaluate that by hand, but luckily, got this bad boy. Let's pop it out. We're going to type in math, alpha, math. That brings up log base. I can type in 4, arrow over, type in 5, and we'll get an approximation here, a decimal. X equals 1609, so let's just say 161. All right? Nice. You could even leave it as like x equals log base 4 or 5. Like, that's acceptable. It's like leaving it in terms of pi when you're dealing with circles, right? But if they ask for a decimal, you'd need to do so, all right? I'll leave that here handy just in case we get caught in another bind over here with the 7. We'll see, though. We'll see. All right. So for this one here, we'll switch over to, how about pink for this one? So we got 7 to the 2x. Okay, I could probably do that again, right? So 7 to the x squared. I'm cool with that. This is interesting, though. We got 7 to the x plus 1. Okay, remember how I backtrack the, power to a power rule is multiplication, then I pull it back out? What rule allows us to add our exponents? When we're multiplying like bases, I can add my exponents. So I'm going to write this in a couple steps. You don't have to do this every time, but could I have 7 to the x times 7 to the first? I could. What's 7 to the first? It's just 7. So now we have this 7 to the x squared plus 7 times 7 to the x equals 8. Boom. That's beautiful. It's exactly what I had before, right? I'm going to make this guy u. So let's say u equals 7 to the x, okay? So we're going to have u squared plus 7u, and I'll subtract that 8 over. It's got to be equal to 0 to use our zero product property, right? Yes, absolutely. Now I can factor. We got u. It's going to be plus 8, and u minus 1. That's going to multiply to negative 8, add to 7. So we'll get u equals negative 8 here, and u equals positive 1. But we got to plug that 7 to the x back in for u. Same here, 7 to the x equals 1. Now, for this one on the left, 7 to the x equals negative 8. Is there anything I could plug in for x that would ever give me a negative number? No. This graph right here, if you were to actually graph it, would look something like this. It's an exponential growth function with a horizontal asymptote of y equals 0. It's never, ever going to get to 0 or below it, so I'm never going to get a negative number. So can't do that one, but I could say that x is equal to 0. So 0 is the only answer that's actually going to work here. And if you were to plug that back in, 7 to the 0, right, that's going to be 1. And then 7 to the first, that's going to be 7. 1 plus 7 is 8. Dang. That's super dope, man. All right. Hopefully those ones help. Those are really the two scenarios that I've seen there. This one, that's always tricky, man. They can even do it with like a x plus 2, and then you might have to square the number and stuff like that. But keep those thoughts in mind there. U-Substitution's here to stay in math. Just getting started with it here in some of these problems. All right. That's it. Have a great day, and keep watching some dope math vids. See you later.